Shetima, primary or first degree alcohol, 1 carbon. Secondary or second degree, 2 carbons. Tertiary or third degree, 3 carbons around.
Hi Shetima tutors. In last video we talked about alkane alkynes.
Shetima. Alkane is a single bond. Alkene bond is a double bond. Alkyne bond is a triple bond.
In this video we'll be talking about alkanols or alcohol, or if you like, OH group. Aliphatic alkanols are compounds in which hydroxyl groups are linked to alkyl groups. They are considered as being derived from the corresponding alkanes by replacing one of the last hydrogen atoms with a hydroxyl group. And ethane is C2H6. So instead of writing C2H6, instead of writing 6 hydrogen atoms, instead of writing 6 hydrogen atoms, remove 1 hydrogen atom and make it C2H5, and then put your all, replace that 1 hydrogen atom you removed by an OH group. It's characterized by the formula Cn H2n plus 1 and then your OH. Monohydric alkanols is written as ROH. We're going to discuss monohydric, dihydric, and trihydric as we move on.
Shetima, monohydric has 1 alcohol or alkyl group attached. Dihydric has 2 alcohol or alkyl groups. Trihydric has 3.
Alkanol is formed by removing the E in the alkane and replacing it with all. Hence, from alkane, it becomes alkanol. Methane becomes methyl alcohol, which is methanol. Ethane changes to ethyl alcohol, which is ethanol, the second member of the series. Remember, the OH group is what makes the compound an alcohol, because OH is referred to as hydroxide, because 1 hydrogen from the alkane is replaced with an OH. Therefore, when you see ROH, you know that it's an alkyl group added to OH. That means R, alkyl group, OH, alcohol. Methanol, ethanol, all are referred to as ROH. Okay, let's look at the formula for propanol, or if you like, propan-1-ol. Why is it propan-1-ol? When do you consider it as propan-2-ol? You consider it by the number of the carbon atom that has the OH group. For propan-1-ol, prop has 3, propane, prop. Then you count. Remember, you start counting either from left to right or right to left. If you count from left to right, you have 1, 2, 3. You have the OH attached to the third one. But if you count from right to left, you have 1, 2, 3. So you have, being that is from right to left, the OH is attached to the first carbon. From left, the OH is the third. From right, the OH is the first. So having checked these 2 directions, you pick the one with the least, which is 1. Therefore, you start counting from the first carbon, OH, since that is closer. Now we notice that the OH is attached to the first carbon, so that is carbon 1. Therefore, the name propan-1-ol.
Shetima, primary or first degree alcohol, 1 carbon. Secondary or second degree, 2 carbons. Tertiary or third degree, 3 carbons around.
Therefore, you can see the formula CH3, CH2, CH2, and then OH. So, of course, this is a primary alcohol. We'll explain that further. It's a primary alcohol because the carbon having the OH group is directly attached to only 1 other carbon. The rest are hydrogen. Listen, the carbon having the OH group is attached directly to just 1 other carbon. Around it, if you look at the carbon having the OH group, check around, you'll see only 1 carbon around it. And that's why it's a primary alcohol. We're going to explain that later. You can see the primary alcohol is also known as first degree alcohol.
Shetima, primary or first degree alcohol, 1 carbon. Secondary or second degree, 2 carbons. Tertiary or third degree, 3 carbons around.
Now look at methanol, ethanol, 1-propanol or propan-1-ol and look at the structure. If we're to examine ethanol, ethanol is 2 carbon atoms, right? And the OH is attached to the first carbon. Therefore, it's ethanol. But it's a primary alcohol because the carbon having the OH group attaches to only one other carbon surrounding it. The rest are hydrogen. Now, we're done with primary alcohol. Let's move on to secondary alcohol. In the case of a secondary alcohol, you look at propan-2-ol. Why is it 2? Remember, can you tell me why it's 2? Because the OH is attached to the second carbon. If it is propan-1-ol, first carbon, propan-2-ol, second carbon. This is different from primary, the concept of primary and secondary, but they're related. But you must note that the propan-2-ol, that 2 in the ol is because the OH is attached to the second carbon. Structure goes as CH3, second CH, then OH, third CH3. Remember, the key way of identifying a primary, secondary, or tertiary alcohol is first, check the carbon holding the hydroxyl group, the alcohol group. Check the carbon holding the alcohol group. Having checked, the second rule is, for that carbon holding the hydroxyl group, I repeat, for that carbon holding the hydroxyl group, I repeat, for that carbon holding the hydroxyl group, how many other carbons are attached to it? In the case of propan-2-ol, the carbon holding the hydroxyl group has 2 other carbons attached to it. As you can see, to the right you have 1 carbon, to the left you have another carbon. Therefore, it's a secondary alcohol. The first one was a primary alcohol because just 1 carbon was directly attached to the one holding the OH group. But in this case, considering the carbon holding the OH group, you have 2 carbons, the one at the left and the one at the right. Hence the name, the secondary alcohol. If you like, you call it second degree alcohol. When it undergoes oxidation, it forms ketones. When secondary alcohol undergoes oxidation, it forms ketones. I repeat, when secondary alcohol undergo oxidation, they form ketones. When secondary alcohol undergo oxidation, they form ketones. What about primary alcohol? Do they form ketones? No. When they undergo oxidation, they can be oxidized to form aldehydes or carboxylic acid. They form aldehyde or carboxylic acid after undergoing oxidation.
Shettima, primary or first degree alcohol, 1 carbon. Secondary or second degree, 2 carbons. Tertiary or third degree, 3 carbons around.
As for tertiary alcohol or third degree alcohol, the carbon having the hydroxyl group is attached to 3 other carbon atoms. I repeat, the carbon holding the hydroxyl group is attached to 3 other carbon atoms. I want us to look closely at propan-2-ol. We've said that earlier, but I want us to take a closer look at propan-2-ol being a secondary alcohol. Look closely. Look at the carbon that's having the hydroxyl group. It's carbon 2, right? But when you look at the right and left, it has 2 other carbons attached to it. So therefore, isopropyl alcohol is a secondary alcohol. Either call it isopropyl alcohol or propan-2-ol. Other examples are 2-butanol. 2-butanol is a good example of a secondary alcohol. Cyclohexanol is also a good example of a secondary alcohol. Now, talking about a tertiary alcohol, you have Tert-butanol and Tert-amyl alcohol. Now, tertiary butanol, look closely, is a third degree or tertiary alcohol because the carbon holding the hydroxyl group is attached to 3 other carbon. It's called tertiary butanol because straight you have 3 carbons, then at a branch you have methyl, which is an alkyl group. So it's Tert butanol, or if you like, you can call it 2-methyl propan-2-ol. 2-methyl, why is it 2-methyl? Because the methyl group CH3 is attached to the middle carbon, 2-methyl, then propan-2-ol, because in this case the alcohol group is attached to the second carbon, to carbon 2. So tertiary butanol is the same thing as propan-2-ol.
Shedema, primary or first degree alcohol, 1 carbon. Secondary or second degree, 2 carbons. Tertiary or third degree, 3 carbons around.
So in the next video, we'll be talking about what if you have other substituent groups attached. How would you call it? From the main functional group, if you have other substituent group, or you have other alkyl groups in the family of methyl, ethyl, and all that, what and how are you going to call that hydrocarbon? Catch you next class.
Shedema, hydrocarbons, hydrogen plus carbon. Prefixes include meth, eth, prop, but, pent,